In general, the regression equation is given by this equation. Y represents the dependent variable for each observation I. Beta 0 is called population y-intercept. Beta 1 is the population slope coefficient. Xi is the independent variable for each observation I. Epsilon I is the random error term. And beta 0 plus beta 1x is called linear component, while epsilon I is the random error component. So the regression equation mainly has two components. One is linear and the other is random. In general, the expected value for this error term is 0. So for the predicted equation, later we'll see that y hat equal b0 plus b1x. This term will be ignored because the expected value for the epsilon equals 0. So again, linear component b0 plus b1xi, and the random component is the epsilon term. So if we have x and y axis, this segment is called y-intercept, which is b0. A change in y divided by change in x is called the slope. Epsilon I is the difference between the observed value of y minus the expected value or the predicted value. The observed is the actual value. So actual minus predicted, the difference between these two values is called the epsilon. So epsilon I is the difference between the observed value of y for x minus the predicted or the estimated value of y for xi. So this difference actually is called the error term. So the error is just observed minus predicted. The estimated regression equation is given by y hat equals b0 plus b1x. As I mentioned before, the epsilon term is cancelled because the expected value for the epsilon equals 0. Here we have y hat instead of y because this one is called the estimated or the predicted value for y, for the observation I, for example. B0 is the estimated of the regression intercept, or it's called y-intercept. B1, the estimate of the regression of the slope. So this is the estimated slope B1. Xi, again, is the independent variable. So X1, it means the value of the independent variable for observation number 1. Now, this equation is called linear regression equation or regression model, which is straight line, because here we are assuming that the relationship between x and y is linear. It could be nonlinear, but we are focusing here in just linear regression. Now the values for B0 and B1 are given by these equations. B1 equals RSY divided by SX. So in order to determine the values of B0 and B1, we have to know first the value of R, the correlation coefficient, Sx and Sy, standard deviations of x and y, as well as the means of x and y. B1 equals R times Sy divided by Sx. B0 is just y bar minus B1x bar, where Sx and Sy are the standard deviations of x and y respectively. So this, how can we compute the values of B0 and B1? Now the question is, what's our interpretation about B0 and B1? And B0, as we mentioned before, is the y-intercept, or the estimate, or is the estimated mean value of y when the value of x is 0. That means if x is 0, then y hat equal B0. So if x is 0, then y hat equal B0. That means B0 is the estimated mean value of y when the value of x equals 0. B1, which is called the estimated change in the mean value of y as a result of 1 unit change in x. That means the sign of B1 determines the direction of the relationship between x and y. So the sign of B1 tells us the exact direction. It could be positive if the sign B1 is positive, or negative on the other side. So that's the meaning of B0 and B1. Now, first step we have to do in order to determine if there exists linear relationship between x and y, we have to draw a scatter plot, y versus x. In this specific example, x is the square feet size of the house is measured by square feet, and house selling price in $1,000. So we have to draw y versus x. So house price versus size of the house. Now, by looking carefully at this scatter plot, even if it's a small sample size, but you can say that there exists positive relationship between house price and size of the house. The points, maybe they are close a little bit to the straight line. It means there exists maybe a strong relationship between x and y. But you can tell the exact strength of the relationship by using the value of r. But here we can tell that there exists positive relationship, and that relation could be strong. Now, simple calculations will give B1 and B0. Suppose we know the values of R, Sy, and Sx. R, if you remember last time, R was 0.762. It's moderate relationship between x and y. Sy and Sx, 60 divided by 4 is 117. That will give 0.109. So B0, in this case, 0.10977. B1. B0 equals y bar minus B1 x bar. B1 is computed in the previous step, so plug that value here. In addition, we know the values of x bar and y bar. Simple calculation will give the value of B0, which is about 98.25. After computing the values of B0 and B1, we can state the regression equation by house price, the estimated value of house price. Hat in this equation means the estimated or the predicted value of the house price equals B0, which is 98, plus B1, which is 0.10977 times square feet. Now here, by using this equation, we can tell, number one, the direction of the relationship between x and y, house price and its size. Since the sign is positive, it means there exists positive associations or relationship between these two variables. Number one. Number two, we can interpret carefully the meaning of the intercept. Now, as we mentioned before, y hat equal B0 only if x equals 0. Now, there is no sense about square feet of 0 because we don't have a size of a house to be 0. But the slope here is 0.109. It has sense because as the size of the house increased by 1 unit, its selling price increased by this amount, 0.109. But here you have to be careful to multiply this value by 1,000 because the data is given in $1,000 for y. So here, as the size of the house increased by 1 unit, by 1 feet, 1 square feet, its selling price increases by this amount, 0.10977, should be multiplied by 1,000, so around $109.77. So that means extra 1 square feet of for the size of the house, it costs you around $100 or $110. So that's the meaning of B0, B1, and the sign actually of the slope. In addition to that, we can make some predictions about house price for any given value of the size of the house. That means if you know that the house size equals 2,000 square feet, so just plug this value here, and simple calculation will give the predicted value of the selling price of a house. That's the whole story for the simple linear regression. In other words, we have this equation. So the interpretation of B0 again. B0 is the estimated mean value of y when the value of x is 0. That means if x is 0 in this range of the observed x values, that's the meaning of the B0. But again, because a house cannot have a square footage of 0, so B0 has no practical application. On the other hand, the interpretation for B1 equal 0.10977, that means B1 again estimates the change in the mean value of y as a result of 1 unit increase in x. In other words, since B1 equal 0.10977, that tells us that the mean value of a house increases by this amount, so multiplied by 1,000, on average for each additional 1 square foot of size. So that's the exact interpretation about B0 and B1. For the prediction, as I mentioned, since we have this equation, and our goal is to predict the price for a house with 2,000 square feet, just to plug this value here, multiply this value by 0.1098, and then add the result to 98.25, will give 317.85. This value should be multiplied by 1,000. So the predicted price for a house with 2,000 square feet is around $317,850. That's for the making the prediction for selling price. The last section in chapter 12 talks about coefficient of determination R squared. The definition for the coefficient of determination is the portion of the total variation in the dependent variable that is explained by the variation in the independent variable. Since we have two variables, x and y, and the question is, what's the portion of the total variation that can be explained by x? So the question is, what's the portion of the total variation in y that is explained already by the variation in x? For example, suppose R squared is 90%, 0.90. That means 90% in the variation of the selling price is explained by its size. That means the size of the house contributes about 90% to explain the variability of the selling price. So we would like to have R squared to be large enough. Now, R squared for simple regression only is given by this equation, correlation between x and y squared. So if we have the correlation between x and y, and then you just square this value, that will give the correlation or the coefficient of determination. So simply, determination coefficient is just the square of the correlation between x and y. We know that R ranges between -1 and +1. So R squared should be ranges between 0 and 1, because minus sign will be cancelled since we are squaring these values. So R square is always between 0 and 1. So again, R square is used to explain the portion of the total variability in the dependent variable that is already explained by the variability in X. For example, sometimes R square is 1. R square is 1 only happens if R is 1 or negative 1. So if there exists perfect relationship, either negative or positive, I mean if R is plus 1 or negative 1, then R square is 1. That means perfect linear relationship between Y and X. Now the value of 1 for R square means that 100% of the variation in Y is explained by variation in X. And that's really never happened in real life. Because R equals 1 or plus 1 or negative 1 cannot be happening in real life. So R square always ranges between 0 and 1, never equals 1, because if R square is 1, that means all the variation in Y is explained by the variation in X. But for sure there is an error, and that error may be due to some variables that are not included in the regression model. Maybe there is a random error in the selection. Maybe the sample size is not large enough in order to determine the total variation in the dependent variable. So it makes sense that R square will be less than 100. So generally speaking, R square always between 0 and 1. Weaker linear relationship between X and Y, it means R square is not 1. So R square, since it lies between 0 and 1, it means some, but not all the variation of Y is explained by the variation X. Because as mentioned before, if R square is 90%, it means some, not all, the variation Y is explained by the variation X. And the remaining percent in this case, which is 10%, this one due to, as I mentioned, maybe there exists some other variables that affect the selling price beside its size. Maybe location of the house affects its selling price. So R square is always between 0 and 1. It's always positive. R square equals 0. That only happens if there is no linear relationship between Y and X. Since R is 0, then R square equals 0. That means the value of Y does not depend on X. Because here, as X increases, Y stay nearly in the same position. It means as X increases, Y stay the same, constant. So that means there is no relationship, or actually there is no linear relationship, because it could be there exists non-linear relationship. But here we are just focusing on a linear relationship between X and Y. So if R is 0, that means the value of Y does not depend on the value of X. So as X increases, Y constant. Now for the previous example, R was 0.76 to 1. To determine the coefficient of determination, one more time, square this value, that's only valid for simple linear regression. Otherwise, you cannot square the value of R in order to determine the coefficient of determination. So again, this is only true for simple linear regression. So R square is 0.76 to 1 squared will give 0.5808. Now, the meaning of this value, first you have to multiply this by 100. So 58.08% of the variation in house prices is explained by the variation in square feet. So 58 around 0.08% of the variation in size of the house, in the price is explained by its size. So size by itself, size only, explains around 50–80% of the selling price of a house. Now the remaining percent, which is around, this is the error, or the remaining percent, this one is due to other variables, other independent variables that might affect the change of Y, that might affect the price. But since the size of the house explains 58%, that means it's a significant variable. Now, if we add more variables to the regression equation, for sure, this value will be increased. So maybe 60 or 65 and 67 and so on. But 60% or 50 is more enough sometimes. But R square, as R square increases, it means we have good fit of the model. That means the model is accurate to determine or to make some prediction. So that's for the coefficient of determination. Any question? So we covered simple linear regression model. We know now how can we compute the values of B0 and B1. We can state or write the regression equation, and we can do some interpretation about B0 and B1, making predictions, and make some comments about the coefficient of determination. That's all. So I'm going to stop now, and I will give some time to discuss some practice.